So, section 2.1, we are now defining what a function is. Up until this point, I've told you, every time I say the word or you see the word function, just think equation, right? And I've said every time you see f of x, where it was that f the parenthesis x, I told you that just means means y, right? Yeah. Okay. Well, both of those statements are still kind of true. But now we're going to actually define what is a function. And from now on, anytime I say function, I mean function. And anytime I use f of x, I mean f of x, okay? And we'll talk about that more tomorrow, the f of x notation, okay? But right now, we want to decide what is a function. So, we start with the definition of a relation. Everything that we have done in this class is a relation. We're talking about how one number relates to another number, okay? And so a relation is just a set or pair of inputs and output values that we can represent in 4 different ways. We have seen relations as ordered pairs. We have seen relations as tables of values. We have seen relations as graphs. We have seen all of those things this year. Every equation we have graphed, every absolute value, every parabola, every circle, everything we've done this year has been with relations, okay? So, something else that you need to make sure to understand. They show it right here, okay? They show it right there, but you've got to know that input and output are just other ways of saying x and y. Okay? Input and output are just other ways of saying x and y. So, since we've seen 3 of these already, let's talk about the one we haven't seen. We haven't dealt with mappings yet, mapping diagrams. And so in a mapping diagram, all you're doing is you're listing your x values. You're listing your inputs and kind of putting them in a bubble or a box. And then you're listing your outputs and putting them in a bubble or a box. And then you're simply drawing that, well, -3 goes to 4. How do I know? Because right here, if I listed the coordinates, -3 goes to 4. Okay, -3 is the x, 4 is the y. Let's see, 3 goes to -1. Okay, 4 goes to -1 and to 3. Why? Because 4 as an x value gives me -1 as a y value and 3 as a y value. Okay, so that's all a mapping is. You're just drawing arrows, basically connecting the ordered pairs. Okay? So, relations can be shown 4 different ways. Now, a function, on the other hand, a function is a relation, but it's a relation in which each element of the domain, or each x value, matches up with only one y value. That is what a function is. Now, we have the words domain and range. First time I've used them in this class. Maybe it's not the first time you've heard them, but for whatever reason, I have the definition down here a little ways. So let's look for the definition of domain. The domain of a relation is all the inputs or x coordinates. The range of a relation or function is all the outputs or the y coordinates. So, anytime that you hear domain, input, or x value, those all mean the exact same thing. Anytime you hear range, output, or y value, those all mean the exact same thing. Okay? So, domain, x values. Range, y values. So, for a function means if I take one x value and put it into an equation, I'm going to get only one y value coming out. I like to think of this as a machine. I like to think of functions as machines. Okay?
Are we supposed to draw that?
Can if you want. Oops. That's not supposed to be like antennas. It's supposed to be another hopper up here. Yeah, you can if you want. You don't have to. Because all I'm going to show you here is that if this is my function, and a function can be any equation, okay? So if that's my function, my inputs are obviously what I'm putting into the function. My outputs are then what are coming out of the function. Okay? So I could have a function such as this. (3x plus 2). And I could say, all right, well, what if I throw in a 2? That's my input. That's my x value. If I was doing an ordered pair, it would look like that so far. Right? I'm throwing in a 2. Now, when I put it into the function says, okay, that means I take 2 and I multiply it by 3. What do I get? 6. Then I take that 6 and I add 2 to it. What do I get? 8. And so then the function spits out a value of 8. Okay? Again, we're changing the wording of talking about basically just substitution. We're plugging into an equation, right? I plug in a 2, I get an 8 for my answer. But to make it a function is that when I plug in the 2, I only get one number coming out. Okay? I don't plug in a 2 and all of a sudden get 2 different answers. Okay? To be a function, when you plug in one number, you need to get out only one number. That's what makes it a function. Okay?
How would you get like 2 numbers?
Well, what if I had a relation that was described as y equals the square root of x? And what if I plug in 9 for x? Remember, we've dealt with it before where we have that plus and minus out in front. And so if I plug in 9 for x, my y value coming out is plus and minus 3. I put one number in, I got 2 numbers out. Okay?
Would you ever like make it so we would end up with 2 numbers?
Absolutely. But it's not a function.
So what do we do? Do we still like put the answer, or do we say like non-function?
Depends on what the question is. I mean, the way you're asking that, I can't give you a specific answer to that. It would all depend on what they're asking you. Okay? All right. So, are we understanding what a function is?
Yeah, are we gonna have to do that?
Do what? This?
Something like that, yeah.
Yeah. You won't have to draw this picture, but yeah, you're going to have to do something like that. Absolutely. Absolutely. Okay? So, let's then practice. They give us a couple of mappings here. We want to determine whether or not we have a function. Okay? So, looking at that first function, first relation, we can't call it a function yet. Looking at that first relation, my first input goes to one output. My second input goes to one output. Third input goes to one output. Fourth input goes to one output. So is that a function?
Yes.
Yes, this is a function.
And if it goes to 2 outputs, it's not a function.
Right, such as the second one. Right? In that second one, our first input goes to one output. Looks good so far. Second input goes to one output. Looks good so far. But that third input goes to 2 different outputs. Can't have that, so that is not a function.
And those of you who had Mrs. Bayer, we did the whole thing about inputs at 0.
So let's go away from the mapping and let's look at ordered pairs instead. So determining whether or not we have a function. So look at your inputs, meaning look at your x values. Does each x value give you only one y value? No. Because 0 shows up 3 times and it gives us 3 different numbers for the output. So therefore, this is not a function.
So you put no or yes? Or
No or yes what? Yep, you can't just say no or yes. We want to say, is it a function or is it not a function?
It was kind of like not mutually exclusive. Mutually exclusive. You can't just say.
All right, so real quick then, I want you guys to look at that second set of points and tell me if it's a function or not. All right, so looking at this, looking at our inputs, we got 1, 2, 3, 4, and 0. So each input is giving us only one output. No one input gives us two outputs, so therefore this is a function. Okay, so let's then talk about domain and range some more. So we've decided whether or not we have functions or not, but even if we have things that are not functions, any relation can have a domain and a range, or does have a domain and a range, okay? That's not specific to just functions, okay? Every relation has a domain and a range. Domain, remember, stands for the inputs or the x values. The range stands for the outputs or the y values. So, if you remember from Tuesday, we took that pretest. That was the first question on that pretest is what's the domain and range given a bunch of points. All they wanted you to do to list your domain is list the x coordinates. I always like to put them in order. So -3, 0, 2, 9, 23. There's our x coordinates. And for the range, it would be -99, -18, 0, 7, and 14.
Please tell me we don't have to put it in order.
Why would you not put them in order?
Why does it matter?
Because that's how numbers show up on the number line, in order. All right, so then looking at the second relation, real quick on your own paper there, please list the domain and the range. All right, seeing some good stuff here. So again, your domain comes from your x coordinates. So we look at the x coordinates and we just put them in order. So -4, -3, 0, and 4. And then the range comes from the y coordinates. And so then again, we put them in order. -4, -3, 0, and 4. Happens to be the same thing for our domain and our range. Okay? So, questions on domain and range?
No, sir.
So, let's head to the backside because we're going to see these things as graphs oftentimes. Okay? It's not always just going to be a bunch of points that they give us. They're going to give us graphs and ask us, is it a function or not? And then what is the domain and what is the range? Okay? So we've got to get used to looking at graphs and finding the same information. So the first thing, to determine whether or not a graph given to you is a function or not, you use what's called the vertical line test. Okay? So the vertical line test states that if a vertical line passes through more than one point on the graph of a relation, then the relation is not a function. So let's take a look closer here. So this is an example of not being a function. Obviously the blue kind of parabola looking thing is the relation we're talking about. Okay? And the vertical line test is the red line. Now, do you actually have to draw in a vertical line? No. You can imagine it. Okay? Because technically for the vertical line, we want that vertical line to go anywhere on the graph. Okay? You don't want to just test it in one spot and say, well, it works or doesn't work there. You want to think of it, well, would it work or not work everywhere? Okay? So, looking at this is an example of not being a function. So I'm just going to write down here, this is not a function. Okay, and trying to tie it together to what we did on the front side of your notes as far as looking at the points and stuff, I'm just going to make up some numbers here for our coordinates. So let's say that this point here is at 1 on the x and 4 on the y. Let's say this is 4 on the x, and let's see here, this is 3 and this is 5. So by doing that, I can now say where those 3 points are located. Okay, I've got that black point located at 1, 4. I've got the first red point located at 4, 3. And I've got the second red point located at 4, 5. And so looking at this now, what the vertical line test is showing us
This 4 goes to 2 outputs.
is that for this, because it's a vertical line, so it's talking about x values, for this one input, we are getting 2 outputs. So for the one input, we're getting 2 outputs, making it not a function? No questions yet? So, okay, let's practice a vertical line test real quick. So off to the side here, you can just look up at my screen. You don't need to write these down if you don't want, or by all means write them down if you want, but keep them onto the side because we're actually going to fill in the bottom of our notes tomorrow. Okay? So what if I have a parabola? What if I have a parabola? Do you think a parabola is a function or not?
Oh, yes, it is.
Yes.
No, it's not.
Okay. Now, first things first. In order to determine whether or not a parabola is a function by its graph, you have to be graphing parabolas properly. Some of you got very lazy on how you graphed parabolas, and you showed me that they would like curve back on themselves. Parabolas do not curve back on themselves. Okay? Also, parabolas, some of you would show the parabola as all of a sudden then going vertical. Parabolas don't actually ever go vertical. So, what a proper parabola would look like is it starts to get vertical, but it's always kind of getting a little bit wider, right? It's always getting a little bit wider. So something like that. So looking at that parabola now, are parabolas functions or not?
Yes.
They are. If your parabola opens up or down, like this one does, then yes, because no matter where I put a vertical line, it's only going to cross that parabola at one spot.
So that's what makes it.
All right, so this parabola definitely passes the vertical line test, so it is a function. All right, let's see here. What if we just have a straight line? Oops, let's change the color. Too late. What if I have a straight line? Is that a function or not?
Yeah. I meant like.
So, absolutely. Every vertical line I draw on here forever and ever, doesn't matter where I put it, it's only crossing that line in one spot, so this is a function. Well, think about that. Are all lines functions then?
What about a straight vertical?
Well, all lines are straight, so don't tell me a straight line.
Okay,
What about
vertical?
a vertical line? Vertical line. Would a vertical line pass the vertical line test? No. Vertical lines are the only lines that are not functions. Okay? Vertical lines are the only lines that are not functions. Because obviously if I drew a vertical line and then did the vertical line test, our vertical line test would cover the entire vertical line, right? And so it intersects it everywhere, so it's not a function, okay? So every other line, though, is, okay? Other than vertical lines, every other line is a function. What about, let's see, we dealt with circles in this class. What about a circle?
No, because it would intersect.
It's not a function, yo.
So, given a circle, you're saying not a function. I agree with you. The circle only passes the vertical line test at two spots. There's 2 points where the circle passes the vertical line test. It'll pass the vertical line test at the left and right point of tangency. That's a phrase from geometry. The left and right point of tangency is where I get a tangent line to my circle. That's it. That's the only places where the vertical line test passes on a circle. Every other place, it's going to cross at 2 spots. Question?
Would there ever be like a horizontal line test? Or is it just straight?
Okay, so there's something else that I want to talk about here, still about looking at the graphs. So there on the right side of your notes, you have that little space there. I want you to just kind of start writing stuff there. We are going to talk about the domain and range if we're given a graph. Okay? If we're given a graph. So if I'm given a graph such as this. Okay? That looks like one of the absolute value equations we dealt with earlier this year, right? Yeah. Is that a function or not?
Yes.
That is a function. It passes the vertical line test. Okay? So that is definitely a function. All right. So looking at this absolute value function, I want to know what is the domain and what is the range. So, domain deals with which values?
X.
X values. Okay, so let's first look at domain for this. We want to list our domain. Now, we're given an entire graph, so am I able to actually just list numbers and say, okay, well, 1, 3, 5, and 7 are in my domain? No.
You gotta put the points.
Well, but are there even numbers that we're able to list? No, because even between 0 and 1, there's an infinite number of values in between there.
Oh, yeah, true.
Okay? So we cannot list everything in the domain, so we have to come up with another way of doing it. But first, let's talk about what numbers are even possible for the domain. So again, domain is the X values. So use your imagination here, and as we are putting ourselves on this function, what's happening to our X values as I walk up to the right of the function?
They're bigger.
My X values are getting bigger, right? As I walk this way up my function, the X values are getting bigger. They're going on that way. Does it go on that way forever? Yeah, that's what the arrowhead in the function means, right? It keeps going that way, so therefore our X values are going to keep getting bigger. Well, what about going in the other direction? What if we walk to the left of our function? What's going to happen to our X values? They keep getting smaller. Forever? Yeah. So therefore, our X values, the possible X values, are all numbers you can think of. The possible X values are all real numbers. Okay? And by the way, there is a symbol for all real numbers rather than having to write that out all the time.
Isn't it R?
It's an R, but you write it a special way. Okay, it's a bolded R. You write it by using 2 vertical lines, and then you turn it into an R.
I did that in 6 times.
Okay? You turn it into an R. You just take 2 vertical lines, make it an R. That symbol means all real numbers. All right? Well, okay, let's talk about the range then. Range stands for which variables?
Y.
The Y variables. So, looking at the function, what is the smallest Y value we can get? 0. We cannot get anything negative for a Y value in this function. Okay? 0 is the smallest Y value we can get. And then as we walk up to the right, or as we walk up to the left, what's happening to our Y values? They're getting bigger. So our range starts at 0, and then it gets bigger from there, right? So if I wrote that as an inequality, I would say that my Y values are greater than or equal to 0. Okay? Now, this, I want you guys to be able to do this. Okay? So this is the first thing I want you to do in your homework when these problems are asked. If they give you a graph and they say, what's the domain and range? I want you to do this first. Okay? But the next thing I want you to do is called interval notation. Okay? For interval notation for the domain and the range, we don't list it like an inequality. Okay? We're listing all the numbers in a special way. We are saying, and it kind of looks like coordinates, but it's not coordinates. Okay? We use a parenthesis for any number that we can't count to. We use a bracket for numbers that we can count to. So, for example, for our domain, to represent all real numbers using interval notation, I want to say that I can go on forever in the negative direction. So we call that negative infinity. And by the way, can you count to infinity?
No.
No, because the biggest number you can think of, there's an infinite number of numbers past that. Okay? Infinity is infinity. You can't count to infinity. Okay? So, therefore, we use a parenthesis to show that we can't count to that. And we're going in the negative direction, so it's negative infinity. Oops, that is an ugly infinity sign. Better, still not good. All right, negative infinity, comma. Where can we go to?
Positive infinity.
We can then go to positive infinity. Okay, and can we count to positive infinity?
No.
No, so we close it off with a parenthesis. So therefore, this notation here means all real numbers. Our domain is from negative infinity to positive infinity. Therefore, everything. Okay, all real numbers. Now, let's talk about the range. How would I write that in interval notation? Well, again, we always start with what's the smallest value. That's why we started at negative infinity. Negative infinity was our smallest value. 0 is our small. Can you count to 0?
Yes.
And is 0 included in our range?
Yes.
Yes. So therefore we use a bracket. And we say 0 to, well then what's the biggest value in our range?
Infinity.
Infinity. And can I count to infinity?
No.
No, I cannot, so I use a parenthesis.
Wow, that's weird.
So this notation is called interval notation. This stuff means the same as what we wrote at first. Okay? So what I want you guys to do in your homework is to write both ways right now. We're going to get to the point where this is all we're writing. Okay? We're going to use interval notation in this class.
You said the bracket means that.
The bracket means that it's included and you can count to that number. Okay? The bracket means it's included and you can count to that number. That's why we don't use a bracket for infinity or negative infinities, because we can't count to those numbers. Okay? All right. So we're going to use interval notation, but I want you to do both right now. That way you can feel the idea that this means this. Okay? And y is greater than or equal to 0 means from 0 to infinity. Okay?